Okay, this is the final video for February 13th. It's the optional one, and it talks about why the recursive equation is the way it is, and why we call it second order differences. So let me refresh your memory. First of all, what is the difference equation for a quadratic sequence? The difference equation for a quadratic what is it? Well, let's see. It's an plus 1 is equal to an plus d0 plus n big D. And a0 is given. Now, I'd already said that the recursive difference equation for the same sequence is something that you can write down too, and that's an plus 1 is 2an minus 1 plus d, and then you'd have a bunch of different options. There are options for a0, a1, or d0, and you get to pick 2 of 3. So why does this formula work? How does it work? How is it true? Well, it's actually not so hard to get the recursive difference equation from the original difference equations. Let me show you it. So what we're going to do is we're going to start off with this original difference equation. Let's copy it. There it is. And what we're going to do is we're going to replace n with n minus 1. So n minus 1 plus 1 is a n minus 1. The d naught doesn't change, and this is an n minus 1. Of course, what's n minus 1 plus 1? Oh yeah, that's a n. D naught, oops, I lost my d, plus n d minus d. Okay, well if I take this equation number 1 and this equation number 2 and subtract them, I'll get something that is the difference between consecutive terms. So let's do 1 minus 2. That's the difference between consecutive terms. That's the difference between consecutive terms. It's also the difference between this and this. Oh no, it doesn't quite fit. Doesn't quite fit. I'll do this then. Oh. Oh no. Okay. Here we go. Okay. So it's the difference between these two equations as well. I've just taken the difference of the left sides and the difference of the right sides. Okay, so let me simplify the new right side. That's an plus, let's see here. You know what I should do? I should go through and see what's what. Yeah, an plus d0 plus nd minus an minus 1. Remember that minus is going to get distributed through. Minus nd plus d. Okay, now look here. I've got a plus d0 and a minus d0. They cancel out. I've got a plus nd and a minus nd. They cancel out. And I'm left with an minus 1 plus d. Now, when you look at this equation, it's a little striking because what's happening here, this is the difference between consecutive terms, just as I said before. Between consecutive this too is a difference between consecutive terms. So this is telling you how the differences change. So this equation explains how the differences and this one here, notice this is recursive. If I move over that a n over to the other side, I get a n plus 1 is 2an minus 1 plus b. Just as I had claimed before. So this was the formula I gave you before. But now the point here is that really what's going on is that these differences here are changing. We should name them something. We should say something like dn plus 1 is dn plus d. That would be a pretty reasonable thing to do, where dn is an minus 1. Which is those differences. I also sometimes use this notation here. So what this is telling us is that the differences indeed follow an arithmetic sequence, just as we had claimed. So that's something that's very generally true. And so what this is saying something about the differences, and let's see here. Now let me do a little trick here. Let's move this over. This is saying the difference between the differences, the second difference, is in fact d. And I think that's a really nifty thing, and that makes quadratic sequences just what they are.